Hello, in this lecture we will find the size of 2 times AP or the value of 2 times AP. In the drawing we have triangle ABC. Side AC of the triangle is equals to 70 units. Side CB of the triangle equals to 50 units. And side ABC, side AB of the triangle equals to 90 units. And we have in the picture a circle that its center is point P, and actually point P is on side AB of the triangle, and the side CA of the triangle is tangent to the circle at a point that we will call that point point O. So side AC of the triangle is tangent to the circle at point O, and also side CB of the triangle is tangent to the circle at point that we will call to that point point E. So side CB of the triangle is tangent to the circle at point E, and we will connect points C and P together. P is the center of the circle. We also will connect points O and P together. So OP is also the radius of the circle. We'll call it R, the abbreviation for radius, because it exceeds from the line OP exceeds from point P, and it touches point O on the circle, so it is defined as the radius of the circle. OP is the radius of the circle, and we also connect points P and E together, and for the same reason PE is the radius of the circle. We will mark it as R. The line PE starts from point P and ends at point E that is on the circle, so it is the radius of the circle. So PO and PE are the radiuses of the circle. They of course equal to each other, and actually we have a rule that if you have a circle and on external point of that circle, let's call that external point of the circle, let's call that point that is an external point of the circle V. It is external point of the circle because point V is not inside the circle nor on the circle, but it is outside the circle. For that reason it is called external point of the circle. And if from point V we will draw two tangents to the circle, that will be the first tangent. Let's call the touching point between the tangent and the circle L, and then we will draw the second tangent to the circle that exits from point V. Let's call the touching point of the tangent with the circle F. So according to the rule that I mentioned, VF equals to VL, because whenever you have external point of a circle and from that point you draw two tangents to the circle, then those two tangents are equal to each other. For that reason, VF equal to VL. So those two tangents are equal to each other. Okay? And for that reason, we can imply the rule in our circle, because we have point C that is external point of the circle. It is not inside the circle nor on the circle, so it is external point of the circle, and from that point we have two tangents to the circle. We have tangent CO to the circle, and from that point we have also tangent CE to the circle. And according to our rule, CO must be equal to CE. So we write it down. CO equals to CE. Okay? According to the rule that I mentioned, whenever you have external point of the circle, that is to say point C, and from point C you draw two tangents to the circle, then those two tangents are equal to each other. That is to say, CO is equal to CE. Okay? And also, as I have already said, we have PO, that is the radius of the circle, and PE is also radius of the circle. So PO equals to PE equals to R. Okay, PO equals to PE equals to R, because both of that lines are radiuses of the circle, so they're equal to each other. Okay? PE equals to PO equals to R. Okay? And also PC equals to itself. Okay? PC equals to PC. So if we look at the green triangle, that is to say triangle COP, and we also look at the black triangle, that is to say triangle CEP. In those two triangles, the blue triangle and the black triangle, we have three sides of triangle COP, the green triangle, that equal to three sides of the black triangle. Why? Because CO in the green triangle equals to CE in the black triangle, OP in the green triangle equals to EP in the black triangle, and CP in the green triangle equals to CP in the black triangle. Okay, so three sides of triangle COP, the green triangle, equals to three sides of triangle CEP, the black triangle. For that reason, we can deduce that the green triangle congruent to the black triangle. Okay, so we can deduce from the fact that three sides of the green triangle are equal to three sides of the black triangle, that the green triangle is congruent to the black triangle. I will write it down. So triangle COP, the green triangle, is congruent to the black triangle, that is to say triangle CEP. Okay, so those two triangles overlap to each other. Because three sides of the green triangle are equal to three sides of the black triangle. This OC equals to CE, PO equals to PE, and CP equals to CP. For that reason, triangle COP overlap triangle CEP. Okay? And we can deduce from that angle OCP equals, this angle equals to angle PCE. I will write it down. Angle COP is equal to angle CEP. Okay, angle I will correct it. Actually it is angle OCP equals to angle ECP. Okay? I'll write it again. Angle OCP in the green triangle equals to angle ECP in the black triangle. Okay, angle OCP in the green triangle equals to angle ECP in the black triangle. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay? According to the rule that corresponding angles in congruent triangles are equal to each other, we can say that angle OCP equals to angle ECP. Because of the fact that the green triangle, triangle COP, overlap the black triangle, triangle CEP, from that we can deduce that angle OCP is equal to angle ECP. Okay? So, if we call to angle OCP theta, then angle ECP will be also called theta because they are equal to each other. Okay? So we will write it down. Angle OCP equals to theta equals to angle ECP equals also to theta. Okay? Angle OCP is theta, so angle ECP is also theta because they are equal to each other. Okay? So, okay, angle OCP equals to theta equals to angle ECP equals to theta also. So now we will draw again triangle ABC. So this is triangle ABC. This is point P, the center of the circle, and this angle ACB is divided to two equal angles, theta and theta. Okay, the angle ACB divided to two equal parts, to two equal angles. This angle is theta and this angle is also theta. So actually according to angle bisector theorem, first of all, line CP is defined as angle bisector because it divides angle ACB of triangle ABC to two equal parts, to two equal angles. Angle bisector CP is defined as angle bisector because of the fact that it divides angle ACB to two equal angles. To two equal angles. It divides it to angle that BCP, that is angle theta, and the other half is also angle ACP, that is also theta, equals to theta. So because of the fact that CP divides angle ACB to two equal angles, it's defined as angle bisector. Okay, and the angle bisector theorem states that an angle bisector that is to say line CP divides the side that it eats. As you can see from the picture, the angle bisector CP eats side AB on triangle ABC, and it divides it to two parts. So the angle bisector theorem states that an angle bisector divides the side that it eats, that is to say side AB, it divides it to two parts, and the ratio between those two parts in a ratio, that is to say AP over PB, in a ratio that equals of AB over PB equals to the ratio of the angles sides. So AP over PB AP over PB equals to the ratio of the angles sides. We relate to the angle that is divided to two equal angles, that is to say angle ACB, and angle ACB consists of two sides, side AC and side CB, and the ratio between those two sides, that is to say AC over CB, equals to AP over PB, because the angle bisector CP divides angle AB to two parts, and the ratio between those two parts, that is to say AP over PB, equals to the ratio of the angles sides, that is to say AC over CB. Okay? Again, an angle bisector, that is to say line PC in the red color, divides the side that it eats. The side that it eats side AB, so, and divides it to two parts. And the ratio between those two parts, that is to say AP over PB, equals to the ratio between the parts of the angle ACB, and the parts, and the ratio between the parts of the angle sides is AC over CB. So AC over CB equals to the ratio of AP over PB. Okay? Again, an angle bisector is CP, divides the side that it eats side AB and divides it to two parts, and the ratio between those two parts equal to the ratio of the angle sides, to the ratio of the angle that is divided to two equal angles. And the ratio of these angle sides is AC over CB. So AC over CB equals to AP over PB. Okay? Again, CP divides side AB to two parts, and the ratio between those two parts, that is to say AP over PB, equals to the ratio of the angle sides, that is to say AC over CB. Okay, so AP over PB equals to AC over CB. Again, I repeat that the angle bisector is defined as angle bisector because it divides angle ACB in the triangle to two equal angles, to angle theta and angle theta. That is the reason that it's defined as angle bisector. And this angle bisector divides the side that it eats, that is to say it eats side AB in the triangle and it divides it to two parts, and the ratio between those two parts, that is to say AP over PB, equals to the ratio between the angle's sides, between the sides of the angle that is divided to two equal angles, and angle ACB is divided to two equal angles and theta and theta, and the ratio between the angles ACB sides is AC over CB, and it is equal to AP over PB. Okay, so I will write again the equation that is derived from the angle bisector theorem. I will mark it as equation 1. AP over PB equals to AC over CB. Okay. Now we will define that AP equals to X, AP equals to X, so PB will be equal to AB minus AP, that is to say to 90 minus X, because AB equals to 90. Okay, AB equals to 90 units, so PB will be equal to AB, that is 90 units, minus AP, that is X. So PB equals to 90 minus X, and CB equals to 70 units, AC equals to 70 units, and CB equals to 50 units, according to the data that we have in the question itself. It is given us that AC equals to 70 units and CB equals to 50 units. So we defined that AP equals to X, and because of the fact that AB equals to 90 units, so PB will be equal to AB, that is 90 units, minus AP, that is X. So PB equals to 90 minus 6. So I will write again that we defined AP that equals to X, and PB equals to 90 minus 6. Okay, AP equals to X and PB equals to 90 minus 6, because PB equals to AB minus PB, so PB equals to AB minus PB, AB minus AP. PB equals to AB minus AP, and AB equals to 90 units. So it is 90 units minus 6. So PB equals to 90 units minus 6. So we can substitute AP by X, because AP equals to X, and PB by 90 minus 6, because PB equals to 90 minus 6. So we'll write again equation 1. Instead of AP, I will write X, because AP equals to X, and instead of PB, I will write 90 minus 6, because PP equals to 90 minus 6. And this is equal to AC over CB. Okay, here I substituted AP by X because AP equals to X, and PB by 90 minus 6 because PB equals to 90 minus 6, and it is equal to AC minus CB. But as you can see from the picture, AC equals to 70 units and BC equals to 50 units. It is given us in the question. So I'll write it down again. AC equals to 70 units and CB equals to 50 units. Okay, so you can write that X over 90 minus 6 equals to AC over CB. Again, I repeat, AC equals to 70 units, so we can substitute AC by 70, and CB equals to 50 units, so we can substitute CB by 50. Okay, here it is the same. Okay, now 70 equals to 7 times 10 and 50 equals to 5 times 10. So I write it down. 70 equals to 7 times 10 and 50 equals to 5 times 10. Okay, so I'll substitute 70 by 7 times n and 50 by 5 times 10. Instead of 70, I will write 7 times 10. And instead of 50, I will write 5 times 10. Okay. Now we have 10 in the numerator, and we have also 10 in the denominator. So we can cancel 10. Because we have it in the numerator and in the denominator, so we cancel it. We can cancel it, or we can reduce 10 from the, or we can reduce the numerator and the denominator by 10, because we have it both in the numerator and in the denominator. So after we cancel 10, we'll get that x over 90 minus 6 equals to 7 over 5. So after we cancel 10, we got that x over 90 minus 6 equals to 7 over 5. Now we can multiply both sides of the equation by 5. we multiply both sides of the equation by 5, so 7 divided by 5 times 5 equals to 7, and x over 90 minus 6 times 5 equals to 5x over 90 minus 6. Now we will multiply both sides of the equation by 90 minus 6. Actually, it is allowable to multiply the equation by 90 minus 6 because as you can see from the picture, AB is actually 90 units and X is less than 90 units, because AB equals to 90 units and X is less than AB, so X is less than 90 units, so 90 minus 6 will be a positive number and it can never be 0. For that reason we can multiply the equation by 90 minus 6. Okay? We'll get that 5x equals to 7 times 90 minus 6. Okay, we multiplied both sides of the equation by 90 minus 6, so 5x divided by 90 minus 6 times 90 minus 6 equals to 5x, and 7 times 90 minus 6 equals to 7 times 90 minus 6. Now we will open the brackets. We will get that 5x equals to 630 minus 7x. Okay, we open the brackets. We get that 5x equals to 7 times 90 is 630, and 7 times minus 6 equals to minus 7x. So we can add 7x to both sides of the equation. So 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Now we can divide both sides of the equation by 6. We will get that so we divided both sides of the equation by 6. So 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. But we also defined that AP equals to x. Okay, so we write it down. We know that according to our definition, AP is equals to x. Okay, so we can write here that 2x equals to 105. Okay, 2x equals to 105, and according to our definition, x equals to AP. Yes, according to our definition, x equals to AP. So 2 times x equals to 2 times AP. So we have here 2 times x equals to 105, and 2 times x equals also to 2 times AP. So 2 times x equals to 105 and equals also to 2 times AP. So we write it down. Two times x equals also to 2 times AP. Okay, 2 times x equals 105 and 2 times x equals also to 2 times AP. So we have here the equation that 2 times AP equals to 105. Two times AP equals to 105. And this is actually the answer to the question. We wanted to know what is the value of 2 times AP, and we got the answer. The answer is that the value of 2 times AP is actually 105, or the value of 2 times AP is equal to 105 units. I will add it. It is 105 units. Okay. So now I will summarize the lecture. Actually, the question was, what is the size of 2 times AP, or what is the value of 2 times AP? And we have triangle ABC in the picture, and the size of this triangle is given to us. The side AC equals to 70 units, side BC equals to 50 units, and side AB of the triangle ABC equals to 90 units. So actually, according to the rule that if from external point of a circle, that is to say from V, you draw 2 tangents to the circle, then those 2 tangents are equal to each other. So VF equals to VL. For that reason, we can say also that CO equals to CE, because from external point of the circle, that is to say from point C, we have 2 tangents to that circle, that is to say CO and CE, and therefore, according to our rule, they are equal to each other. So CO equals to CE, and also PO equals to PE, because they both the radiuses of the circle, so they are equal to each other, and CP equals to itself. And for that reason, because of the fact that 3 sides of the green triangle equals to 3 sides of the black triangle, we can say that the green triangle, that is to say triangle COP, congruent to the black triangle, that is to say triangle CEP. Okay, so triangle COP overlap the green triangle overlap triangle CEP. Okay, and from that we can deduce that angle PCO is equal to angle PCE, and we call those angles theta, according to the rule that corresponding angles in congruent triangles are equal to each other. For that reason, if this angle is theta, this angle also must be theta. Okay, so and then we draw triangle ABC again, and so this is triangle ABC, and actually PCP is the center of the circle, and PC divides angle ACB to two equal angles. This angle is theta, so this angle is also theta. For this reason, PC is defined as angle bisector. And we have the angle bisector theorem that states that the angle bisector, that is to say PC, divides the angle that the side that it eats, that is to say side AB, CP eats side AB, and it divides it to two parts, to AP and PB, and the ratio between those two parts, the ratio of those two parts, that is to say AP over PB, equals to the ratio of the angles sides, that is to say AC over CB. So AP over PB equals to AC over CB. Again, the angle bisector CP divides side AB to two parts, part AP and part PB, and the ratio between those two parts, that is to say AP over PB, equals to the ratio between the angles sides, between the angle that is divided to two equal angles, that is to say angle ACB, and the sides of angle ACB is side AC and side ACB, and the ratio between those two sides, that is to say AC over CB, equals to the ratio between AP to PB, that is to say AP over PB, or AP over PB equals to AC over CB. Okay, so from that equation, we actually define that AP equals to X and PB equals to 90 minus X, because AB is 90, so 90 units, so PB equals to AB minus AP, that is to say 90 minus X, and so we can substitute AP by X and BP by 90 minus X, and also we can substitute AC by 70 because AC equals to 70 units, and BC by 50 because BC equals to 50 units. So after we do all the calculations, we got that 2x equals to 2 times AP equals to 105 units. Okay, 2 times AP equals to 105 units. Okay, thank you very much.